we're ready to rock and roll. I'm Jerry May. I'm from MSU Extension and part of the planning committee that's helped put this together. This is Double Eagle Dairy, and as you were pulling up, John said this is the bus we've been looking for. It's the fourth, and so really encouraged by the number of people that have participated and the discussions that we've had. I hope you share that this has been a very good day. At this stop, we have myself and Dr. Steve Safferman from Biosystems and Ag Engineering at MSU. What happened to Josh? We lost Josh Weller. He's our tour guide once we get done with this side, but we'll catch up with him. And then at the corner of the door there, we have John Weller from Double Eagle Dairy. So what we're going to do is we'll talk a little bit about our poster here, and then we're going to go and give a tour of the processing system. And John had a good question between the first and the second bus this morning. He says, why are you guys doing these things? You know, what's the purpose? And it's really not for you to go home and think, oh gosh, we have to install this type of system. It goes back to what more of what Amber was talking about is finding what works for you. And if this helps plant some seeds and start some discussion and some thinking, that's why we do this. It's not to think that in Clinton County we're going to have 100 miles of buffers or anything like that, but start to think about what process might work for your particular farm and for your particular system. I'm going to review just a little bit of this poster, and then I will turn it over to Dr. Safferman and he will finish up on the poster. When we have cows on our farms, we get more than just milk from them. We get approximately 150 pounds of manure a day, and that's excreted manure. That's not including all of the other water that we add into that, the surface waters, the feed pad waters that we collect. So we have that, and then 87% of that is actually water. And so systems like what Wellers have installed here are starting to think about, well, let's take the water out, so then we're handling just the solids, and the waters then can be used for other uses. Within this manure, we have almost a pound of nitrogen, almost 2/10 of the pounds of phosphorus, and almost or over 2/10 of a pound of potash. The problems with those are all good nutrients, and we think of them as crop nutrients. The problem is, though, that they aren't always in the ratio that you need them for crop production. And so in this type of system where you start to separate out the solids and then taking out the different components as different steps along the way, now you've got them separated out, and you can hopefully apply them or land apply them or process them for other uses, at least for the crop nutrient needs. So why do we separate? Farm expansion could be one. Your dairy farms, but you're not going to add more cash crop. You separate out the manure and the fibers and the nutrients, and then you can either process them or provide them to cash croppers for their use. There is a good deal of environmental protection involved here. We've removed the water. As Amber talked about, then now maybe we can do a little better job of keeping them on the fields, less runoff, and in the root zone for crop production. Some communities are starting to watch the amount of pathogens that are in their waterways. And this particular system here will remove the pathogens. Now that doesn't mean they've gone away, but we've removed them out of the water. There's less likelihood that they're going to get into surface waters. We've put them into the solids, and you have the option of field applying them and making sure that they don't get in the waterways, or if you want to, you could compost them and further clean up the product. There is some monetary savings or potential for monetary savings. Dr. Safferman will discuss that a little bit more. If you're not having to store all of the manure, there's the cost involved with manure storage and manure application. And as you take the water out, there's less manure to apply and less manure to store. We talked about the optimizing use of nutrients as you separated them out. And then we've got an almost clean water coming out of this particular system once it's up and running. And you have multiple uses for that particular water source. You can store it and irrigate it. You can recycle it into this system. You can use it for fresh water. And so there's multiple options for that.
I do want to recognize the Wellers for opening up their dairy farm for us today. And the most important part of this stop will be the tour that they're going to provide, where we can ask them lots of questions about the equipment that they have at their facility. So what I wanted to talk about, though, is the general concept of manure separation. And every farm is different. It depends on the management style of the farm. It depends on the objectives of that farm. But I tried to put it into four basic steps. And the first step is a pre-treatment step. And this has to do with getting that water and manure to separate, because as is, it's very hard to get that water out of there. You can't just put it into a screen or a filter. It won't separate. And there's a couple options that's commonly used. Each of these are commercially available. One is the anaerobic digester, so having that manure circulate for 7 to 15 days to 20 days definitely releases that water. But also there's a chemical physical type system, and that's what we're going to see here, where we can use coagulants and polymers to try to get that separation to occur. So this is kind of our first separation, our coarse separation. We can then go on to the separation of the nutrients. So most of the time we have a kind of a more of a rough separation, and this will actually get rid of most of the phosphorus, because if you look at this graph here, most of our phosphorus is particulate. And so all the particulates will be separated here, and about half the nitrogen, since half the nitrogen is in the particulate form. And this is this process is either going to be an ultrafiltration unit, a belt press, a centrifuge, or a screen. So here at this facility, we're going to see the screens and the belt press. The ultrafiltration is a newer technology. I have a picture of one down here. This is basically 20 or so channels in a pipe, and the water goes through that, and the clean water goes out the sides, and the concentrated material goes through. So if you do treat just with ultrafiltration or screens, you get actually a pathogen-free water. All the pathogens will go out, and you get a reduced nutrient water. So the end point on this water could be irrigation. You probably would still have to look at the nutrient requirements of your crop and agronomically apply that water. So you have a couple options if you decide to go further and want a cleaner product. And one option is to go to ammonia stripping. So we do now still have the dissolved materials in here, including ammonia, and it's actually pretty trivial to strip that out with a two-phase stripper, and we get ammonium sulfate out. We actually dry this to get ammonium sulfate fertilizer. That's one option. We can then go to an RO unit, or we can go directly to the RO unit. And so you're seeing an RO unit right behind me, and this is reverse osmosis. And this is another membrane process, but a lot different. Instead of these channels, this is actually wound. It's spiral wound, and it has a very, very small porosity. Metal salts, all the dissolved nutrients, phosphorus, nitrogen, potassium, all will be removed through this membrane. In fact, this is about as clean as you can get water using any sort of technology except for distillation. In other words, heating up the water and then collecting the stuff that evaporates off. So it's a very, get a very clean product after this membrane system. But it's very important, if you have a membrane system, that you have a good pre-treatment, because the life of these membranes, the maintenance of that membrane depends on the pre-treatment steps. And so at this particular facility, the membranes will be housed over here, but the membranes are actually back in those boxes behind us. So they'll get ready to install those membranes in the near future. So how much does all this cost? I'm going to exclude the front half and just look at the true nutrient separation. And the cost I've seen from manufacturers is about 2 cents a gallon. So that includes going through ultrafiltration, air stripping, and RO, which is actually surprisingly economical, because if you think about how much it costs to store your water, your manure, and then haul it in your tractor in a tanker, that's about 1 to 3 cents a gallon, or average is 2 cents a gallon. So when Jerry mentioned the potential cost savings, you can actually offset the cost of that hauling, because you can now irrigate this water. This water is actually of quality that it's could be surface discharged. And you can also even use this for cow comfort, for cow cooling, and technically even cow drinking, because it's so clean. So very flexible, a lot of flexibility using this water. right on site instead of having to move it to pay for hauling it off site. The other advantage is you do get your nutrients segregated, and theoretically then you could optimize the blend of nutrients for your specific crop needs. And that could have advantages of, again, minimizing the trips on and off the field. So with that, I would like to introduce Josh Weller, who's was involved in designing, building, and now operates this facility. So he's going to lead the tour of the facility and answer questions, and he knows everything about this. So Josh, I'm going to turn it over to you.
All right, when you see all the vac truck come in here, we have a sucker tank that sucks up all the manure out of the barns. So it comes in here and dumps it out. He's got first press the button over here. Let the flush pump go out there. You see all the water coming in there, it sends the water down and it mixes in with the manure. We want the manure to stay suspended. We want the sand to fall to the bottom. There's two augers that will auger the sand all the way down to the sump hole where these two incline augers are at. And there's another augers bringing it this way from the other side of the channel. We want to catch most of the sand right in this sump hole to auger out into the sand washers. If you want to follow me over here, we can see more clear of the sand washers. All right, as you can see, the sand, there's a hole that's about 4 foot deeper than the trench over here. The sand will also come up, and the incline augers go up into the sand washers. As with the sand and the fiber that's in the sand will come out, go down the side of these sand. The sand washers, the water and the fiber will go into this DT machine over here, and the fiber will be sorted out in a rotary screen. The water will get pumped up into the poly tanks, and the poly tanks will be gravity fed back to the water over here. So the water is going to regurgitate itself back and forth for about 8 hours, and one of these poly tanks will be dumped and fresh water will be added in. That's how we get our fresh water into our system. When that system gets all done, we should be able to pump water over here from there. So we can take over here, where it comes out of the sand washers, you see it kind of just slumps down into the sand washers, or the sand shakers. Sand shakers will de-water the sand, and then we go around the corner, you guys can feel the sand and see how dry or wet it is. It's very clean and dry. So right here you can see all the water that comes out of the sand, and the sand will be just shaken out. And then we got any questions on this? You guys more fairly fill the sand and see how it is. It doesn't bite.
Yes, dry it after?
No.
How soon can you use this? Are you storing this outside or you?
No, actually, I'm hoping
Back in?
when vets come back with the samples, I'm hoping 3 to 4 days it sits in here. That's only been since Friday, that pile of sand. I'm hoping that we can fill this side up, and then we start filling this side up.
Just started running?
No, I've been running the week before 4th of July.
No.
So, I mean, we got a boatload of sand over there from this barn.
Brand new.
Yeah, it's brand new, yeah. We're hoping not to. But we did before. As you guys can see over here, this is a sand lane. We hope to get 95% of the sand in the sand washers and shaken out. Right now, when a new system gets put in, you're gonna have fine sand. There's fine sand in the sand that you guys buy. But the fine sand will land in here, and it'll get carried over here, and we're gonna throw it out. So you don't want the fine sand anymore. It plugs up your system, and it doesn't like to work very well. So sooner or later, when we're all said and done, when the system, we run the sand that this barn makes, put it back through this freestalls, it gets sucked back up. The sand out of here, we dump back in the auger channel, and it'll get put back into the sand washer, we hope, and we get to reclaim all of our sand. So we shouldn't throw any more sand out of here anymore. We should be able to reuse all of our own sand, and sooner or later, we might have to add sand in. We don't know. Anybody got any questions?
Is that as dry as it'll get?
Unless you set it outside. Yeah, that's finished product right there. Okay. That's finished product right there.
Do you take it outside to dry it at all?
We're hoping not to.
Okay.
That's finished product right there.
Okay.
That's done with the sand. This is all the sand side. I explained to you this is all sand. And we'll go on the other side and I'll explain the solids and stuff like that.
Are you using this for bedding?
Yes, we're all sand bedding, except for like our fraternity barn. And all right, here we have a hole with a bunch of pumps and motors in here. See what I was saying, where the water comes from the sand lane over there, there's 2 tanks. There's a tank underneath all the equipment over here. There's another tank over here. They're each 14,000 gallon tanks, which these pumps will pump the manure. There's 2 flush pumps. You guys saw the water coming out of the auger channel over there. That water just circulates so the manure stays in there. So there's 2 more pumps that'll go to the slope screens. The slope screens will de-water and get the solids out. And then it'll go into a roll press. Then it'll go down to another roll press. And that squeezes all most of the liquid out of it. And it'll get carried out to this discharge auger. There's 2 more for the McClanahan screen. They're rotary screens. They circle. They're a lot finer screens than the slope screens. And they get dumped into just one single roll press. And the solids get discharged out. And there's 2 more pumps for the accents. Those are the finest screens that we got. And then that gets discharged in the LWR system. So our LWR system starts here. This is the water treatment part. This pump will pump it over there to that line, that 4-inch line that comes out over there. It'll get put in with some polymer. It'll go up to these silver flock tanks where the motors are sitting on top. There's paddles in there that will spin to bring the nutrient stuff on to the micro screens. The micro screens will get the rest of the finer solids out. Then it'll go down into the screw presses out of the orange thing. And then that will squeeze out the rest of the solids, and those will get discharged out of the building. And the water will go into the tanks underneath the micro screens, and those will get pumped over to the clarifier. Then there's another polymer chemical that gets added into that. And once it goes through the purifier, then we go on the other side to the LWR. We go to the RO skid. Has anybody got any questions about anything? Yes. Thank you. I forget about that every time. Right now what we're doing, because the LWR system is not working, because we don't got it all put together, there's a discharge out of this tank. This is our cleanest water. The water will flow over to the discharge where the green pipes are above ground. That is our cleanest water out of the whole barn right now. And when you guys go over to the LWR, I'd like you guys to take a look at it. It is clean. Yeah, it's got a lot of the fibers out of it. It doesn't have all of it out. That's what the micro screens are supposed to do. But it's taking majority of the fiber out.
So is that going to go in the RO system, or is what's coming off the refiner?
What comes off of here? See right here, instead of it going to the discharge tank, it's going to go to this tank. This tank's going to get pumped over to the flock tanks, and it's going to go through the LWR system. That clarify or no? Yeah, the LWR is after this one, after the purifier. It's got this stage, that stage, then it goes to the LWR. But it gets like 3 polymers before it gets over there. Then it adds more chemicals over there. All right, you see we have the RO skid here. This is the final step. The water after the purifier, after the big blue box, what do you want to call that thing? Call it purifier, but comes in here. It gets more chemicals mixed in here, and the membranes, which he mentioned earlier, are sitting over there. They will go actually in each PVC pipe, and the water will get treated. And when it's all said and done, when it's supposed to work how it's supposed to work, is you'll be able to drink the water. Cows will be able to drink the water. We'll be able to use misters, but for a startup right now, we're hoping just to get irrigated, so we can just irrigate our fields with it. But our long-term goal is to reuse the water, to drink it, to recycle into our farm, and the barn will be used on its own water. Has anybody got any questions? Define investment. The dollars I invested in this? I don't know. I don't deal with the books. I just deal with the equipment. Guy that deals with the books, he's out there. Hey, you know, if it saves money on trucking, that's a lot. I mean, just by running off some numbers in my head, it's probably 3 or 4 year payback if it works properly. Well, you're reusing your sand, you're getting fiber, and you reuse your water. So I mean, I hope if it works right, we can put misters in our barn. See, we don't want to put misters in our barn because we don't want more water in our manure. But if we can recycle our water and use that, we can cool our cows. We hope we can produce more milk, and all around it'll be, everything will just go right up. Hope so. Right. That's the goal. Anybody else got any more questions? Yes, ma'am.
What will we do with the fiber after you've got the nutrients out? How much fiber will be left? What can you do with that?
You'll see outside, ma'am, there's a lot of fiber. There's a lot. No, I will put on our field. It's just like cow manure. It's 75% moisture, and the phosphate's low in it. And or after the microscreens, that's the good stuff. That's good stuff we got to mix in to make the other stuff a little more potent. So you just spread it on a field with a spreader or something. But it's a lot easier. We can manage hauling it a lot easier. That we don't got to pay someone else to come in and haul a bunch of liquids.
That's where you can save.
Where you can save is all we got to do is haul the fiber. We don't got to haul the liquids. That's what we're going to save.
You're mixing all the liquid back together, or you keeping the high phos stuff separate?
No, what I was talking about, the micro screens over here, there'd be fiber just like it coming out of the auger channel, but it's going to be the higher nutrients. Because right now, I think 60% of the nutrients in the stuff is in the water still after.
100% of the liquid is going to go through here, and
Yes.
that's what you get.
Yes. Like the fiber that comes off the micro screens is the stuff that you really want. Because after that discharge tank, there's still high nutrients in that water. And that's the high nutrients you really want for your fields. Any more questions? If not, we'll go around back and I'll show you the silage the pile. See all of our solids here. About every hour, hour and a half, he's taking about 15 bucket loads out of the auger over there. It's by that kick out of that barn over there. And he is stacking it. And then all the rainwater, we do catch all the water here on this pad. You can see. By that board, there's a hole that takes to that discharge tank, and it does flush into our pond because we do legal rights. We have to catch all of our water here. So, and you guys are more free. This is the sand that's been sitting outside for a week. You guys can see that, and then there's all the solids that we've accumulated over the last month and a half. Anybody?
How many months storage are you supposed to have?
6 months storage here. Doesn't look like it, but we do. Just got to pile it higher. Right. You guys more freely. You guys can feel the fiber. See how wet it is, how dry it is.
It's a little wetter product than what you saw up at Banner.
Because they're bedding with their stuff. That's why.
Yeah, it's better, but it's, you know, I have my truck. I don't think I will.
Come by, I'll give it to you.
You finding a lot of the nitrogens coming out with these fines, or is it still
No.
in the water?
It's still in the water. I think what we test? 6% of it's still in the water, I think.
Most of the phosphorus.
Yeah. This stuff is low, and I mean, to get to what you want, you got to put a lot on the acre. I mean, we'll burn through it fast, probably.
You know how much polymer chemical cost is going to be a year?
I don't know the cost in the comment. We haven't